So now I'm going to talk about a new quantity which is used in alternating currents, and that's the root mean square quantities. Because we have a problem, if we look at the graphs of voltage against time, if we were to find an average value for voltage, if we were to add up all these values and divide by the sum of the values, we would get an average of 0. So taking a normal average doesn't work. What we have to do is to take what's called the root mean square quantity, or RMS. And there is a derivation for this, but I'm not going to go through it. Basically, if we have the peak value, which is the maximum value of the voltage given by reading off at the maximum, then the RMS value for the voltage, which is denoted VRMS, is equal to the peak value for the voltage divided by the square root of 2. Now, square root of 2 is roughly 1.4, so 1 divided by 1.4 is 70%. So the RMS value on this graph would be about here. Likewise for current, the RMS value for the current is equal to the peak value for the current divided by square root of 2, which again is about here on the graph. Then we can also talk about the average. By combining these two, we can also talk about the average current, or P bar. Bar is commonly used to denote averages. That is the same as the peak voltage times by the peak current divided by 2, which, replacing the peak values with our new quantities for RMS, gives us root 2 VRMS, just substituting here, times root 2 IRMS divided by 2. Root 2 times 2 is 2, so this just becomes, these quantity cancel, and I get the average power to be the RMS voltage times the RMS current.